Hi, and welcome to Newly Greens. This has been a busy year for us.
Indeed it has. We started out the year with an energy audit, and that revealed a number of projects for us to tackle.
And tackle them we have, and we're going to share what we've discovered with you to maybe help you better prepare for the next chilly season.
In this segment, we're talking to Pete Monahan from Beta American Services, and they're the team that replaced our old dinosaur of a boiler with a new super high efficiency heating system.
Beta American Services specializes in heating and air conditioning systems, high efficiency, geothermal heat pumps, condensing boilers, air source heat pumps, energy efficient ductwork. Your old boiler is a Janitrol 405,000 BTU boiler. It's hot water. It was running about 50% efficient. It had a lot of thermal mass to it, which takes a long time to heat up.
What is it that we have going for us in terms of the old system? What are the good things about the design?
Radiators are an extremely efficient way to heat a house. You could heat the house with a lower water temperature. The cooler the water coming back to the boiler, the higher the efficiency. So your existing piping system lends itself well to a condensing boiler.
Pete, our radiators are fed by hot water, but I know many run on steam. What's the difference?
The best you'll ever do with steam efficiency-wise on a boiler is 82%. And that's because you can't lower the water temperature. You have to boil the water, and you have to be up at 212 degrees. The lower the water temperature, the higher the combustion efficiency is.
A couple of years ago, we toured the Near Zero home in Paterson, New Jersey with Jack Armstrong.
Jack explained that the stone wall in the dining room acts as thermal mass in the house. What that means is that during the day, the wall will absorb thermal energy. And at night, it will slowly release that energy back into the house. This reduces fluctuations in temperature that could cause your furnace to cycle on using more energy. It keeps your house at a more comfortable temperature.
These antique radiators bank heat energy in much the same way as a stone wall, and that's why they're now sought after as people try to use energy more wisely. Those old-timers were obviously onto something. However, they couldn't get everything right. Boiler designs and how we insulate have changed radically since this house was built 100 years ago. Let's get back to Pete as he tells us the bad news about our old boiler.
So a lot of the heat went up the flue system because it was inefficient, approximately 45%. Your existing system was designed for the coldest day of the year. So we have a lot of surface area on all your radiators to be able to heat this house and keep it at 72 degrees when it's basically 0 degrees outside. But every other day that it's above 0 degrees, we don't need all of that horsepower. And your original system was designed with your house having no insulation as well. You've done an energy audit and you've tightened up the house, insulated all the walls, and sealed it up. So we were able to drop the capacity all the way down to 250,000 BTUs, and we modulate down from there. Your new boiler will be a modulating condensing boiler, which means we have a variable gas input. So you're going to gain a lot of efficiency from this new boiler.
So unlike our old boiler that gave us an all or nothing solution, this new boiler is basically smarter in that it only uses the energy it needs to keep us warm. The big question for me, though, is are we going to trade comfort for this improved efficiency?
You'll notice that your radiators are going to be cooler when it's more mild out, and they're going to get warmer as it gets colder out. And that's because the boiler is changing the water temperature inside the piping based on outside air temperature. When you're in the 40s, we're going to run, say, 145 degree water through the system instead of 180 degree water. As we get down closer to 0, we'll be running 180 degree because that's our design water temperature.
When Pete says that our old boiler was about 50% efficient, that means for every dollar we spend on fuel, we only realize about 50 cents worth of heat. Now our new boiler is going to run it closer to 94% efficient. So right there, we're talking about 94 cents on the dollar being used versus 50 cents on the dollar. And that's serious savings. To accomplish this, the entire design of the new boiler is different.
You'll notice that there's actually 2 flue pipes coming out of the existing chimney. What's going on inside the chimney is that we ran the exhaust pipe in PVC all the way up through the chimney, a solid piece, and we went up through the chimney cap. It's a little bit more work to go up the existing chimney with the PVC pipe, but it's a much cleaner job. You're not going to see steam in the backyard. It's just a neater installation. The second pipe that you see going into the chimney doesn't go all the way up the chimney. That just goes into the base. And what we're doing is we're using that as a fresh air chaseway, the rest of the chimney around the other pipe, to bring fresh air into the boiler for combustion.
The audit and improvement projects have really driven home the idea that our entire house and everything in it is an interconnected system. All the parts interact with each other.
Right. Now, anytime you have a flame, it needs oxygen to burn. Now, with a conventional boiler, we'd use the air from our basement to feed that flame. The problem is that as the boiler burns...
That sounds like a soap opera. As the boiler burns.
Okay.
Come on, doesn't it?
Yes, it does.
I know.
And just like a soap opera that sucks the life out of young actors, the hot air rushing out of the chimney
nice.
actually turns the chimney into a giant straw.
Oh, yes. That hot air rushing out also sucks the cold outside air in through the little cracks and crevices.
Right. Now, we solved this problem by having a dedicated pipe that brings the outside air directly to the new boiler. Now, the boiler no longer sucks air in through all the walls and windows that would chill the house.
The next cool trick our new boiler has is the ability to capture heat from the exhaust gas before it is lost up the chimney. This is called heat recovery or condensing.
There's a secondary heat exchanger inside this that you can't see because it's, it's welded inside the heat exchanger. And that's where we scrub that heat out of the flue gas and keep it in the house. Instead of exhausting it out the chimney, like your old boiler did, this one scrubs the heat out of it and we keep it in the house. We redeposit it back into the return water and use that heat energy to heat the house.
Now, since we're trying to squeeze every little bit of efficiency out of this redesign, Pete had one more modification from our original system.
Okay, basically these are your circulator pumps for each zone that you have.
Okay.
Before you only had one single zone, and now
Which
we were
was
able
crazy.
to. Yeah, it was
Yeah.
crazy. Yeah. But this allows you to have different temperatures in different areas of the house.
right.
The original
Intact.
plumbing
Yeah.
was set up so that it could have been zoned, but they didn't do it. The only problem that we did have is that you didn't have any thermostat wires, and that's why we had to use the wireless thermostats, which worked out very well.
Right.
So basically what happens is the thermostat tells this box, I want heat. This box tells this box, I want heat.
Okay.
And each wire that goes to the pump for the zone that's calling energizes the circulator, and we start to move water through it. And it tells, this box tells the boiler, turn on the burner, turn on the circulator.
Right.
This pump right here is the pump that circulates water through the boiler. This needs to have its own circulator pump to make sure that we have the right flow.
How is that different from the old boiler? Because that was huge.
Your old boiler was a
Huge.
giant pot
Yeah.
of water and a lot of cast iron, and it took, at least a half hour to heat it up.
Yeah.
And then, it didn't need to move the water out of it because it was so slow at heating. This is very efficient, and it quickly heats the water that's in the boiler. So we want to move that heat out of the boiler and move it into
Yep.
the zones that are
Yep.
calling.
Yep. Oh, Pete, thank you so much.
Oh, no
This
problem.
was really great.
Thank
This
you.
is really informative, and she's a beauty.
Thanks for letting us install it for you.
Sure. Thanks for giving us all our room back in the basement.
No problem.
So, we have had the new system up and running for several months now, and I am happy to report that the combined improvements of both boiler and air sealing have reduced our heating bills by about 47%. Yes!
And when you figure in the rebates we got back from the state on this project, that means these improvements should pay for themselves in about 5 years. And that is money for nothing.
And your greens for free. And that is good for the earth.
And that's good for you. Thank you for watching Newly Greens.